Assignment number 4, Bohr model introduction. By the end of this video, you'll be able to draw a Bohr model, something that looks similar to what I circled there in green. It'll show the number of protons in the nucleus of the atom and the number of electrons and the electrons in the appropriate energy level with the appropriate number. There is often, I observe about half the students just going along, not even actually listening to me talk, first of all, and then not really trying to learn and understand what it is in the video. They're just writing things down. If that's the case, that's your decision to do that. However, you're going to get to the end of the video and not be able to draw a Bohr model. And the assignment immediately after this video, excuse me, is to draw a couple of Bohr models. You're going to draw those. You're going to bring me your paper. And when you can't do it, how I'm going to help you is by telling you to come back and watch this video again. So it makes sense to figure this out the first time, not have to waste a class period, get behind. Now you know how to do it, and I'm telling you, go watch the video again. So pay careful attention, recognize that this is the learning activity. This is not something for you to just hang out today and do, and then you'll figure it out later. This is how you're going to figure it out. You either do it now or you watch this again later and figure it out then. Bohr models show the subatomic particles and their location. If you remember, subatomic particles are protons, neutrons, and electrons, and that electrons are arranged in energy levels called orbitals or shells. The orbitals or shells, this is orbital or shell 1 right here in green. This is orbital or shell 2 right here in red. This is orbital or shell or energy level 3. All those words mean the same thing. Orbital, shell, energy level 1, 2, 3. That's the rings around the nucleus, which contains the protons and neutrons. There were the answer to question 1 and 2 on your assignment number 4 paper. Bohr models show all subatomic particles in their correct location. Bohr models show electrons arranged in energy levels or orbitals or shells. That's answers 1 and 2 on, assignment number 4 paper. Bohr model with electrons arranged in energy levels called shells. Again, these circles around the nucleus are called energy levels or shells. Energy levels, orbitals, shells. All of those names apply to those things. Number 3 on your assignment number 4 paper, the areas around the atom containing the electrons have more than one name. What are the 3 names for the rings where electrons are found? Orbitals, energy levels, or shells. Again, the goal of today is to be able to draw a Bohr model, and you've got to know what those energy levels or rings or areas where electrons are found are called. Orbitals, energy levels, shells. Number 4 on your paper, each particular energy level contains a maximum number of electrons. The first energy level can hold a maximum of 2. You have to memorize this. 1, 2. The second energy level can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. And the third energy level can hold 18, and it goes beyond that. But in your freshman year, you really only need to know 2, 8, 18, 32. So the first energy level holds 2. Second energy level can hold a maximum of 8 electrons. The third energy level can hold a maximum of 18 electrons. And the fourth can hold a maximum of 32 electrons. You're going to need to remember that. 2, 8, 18, 32. That was number 4 on your paper. Number 5, when constructing Bohr models, electrons fill the blank energy levels first. The electrons go in the first energy level and you work your way out. So when we decide to draw electrons in this atom, we're going to draw these 2 first. There's electron number 1 and 2. Once that energy level is full, the first one holds 2. We go to the next energy level. The second energy level can hold up to 8. So if it's full, we would draw all 8 of those in there. If it only has 3 left, then we would draw 3 in there. Number 6 on your paper says the lowest energy level is the one blank to the nucleus. The lowest energy level is the one closest to the nucleus. This one has the lowest energy. That's the one that fills first. The energy level with the highest amount of energy is the one out here, and it would fill last. If you think about these electrons orbiting like planets, if you've got a little bit of energy, and this is the sun in the middle, if I've got this electron right here, and it has a little bit of energy, and it tries to get away from the sun, and the sun's gravity pulls it back, and now it tries to get away this way, and the sun's energy pulls it back, and it tries to get away that way. If I give an electron a little bit more energy, I push it away harder, it could go farther, and then it gets pulled back, it goes farther, and gets pulled back. So the more energy you have, the further away from the nucleus the electron is able to orbit. So closest to the nucleus, low energy, furthest from the nucleus, or higher energy level is further away. And that takes care of 7 and 8. Electrons fill the energy shells or levels in order from low to high energy. So now, steps for creating a Bohr model. You've got 2 examples on the back of your paper. You need to determine the number of protons, neutrons, and electrons, which we've already practiced a bunch. You use your square off the periodic table. For example, if this is carbon, number 6, mass of 12.01, how many protons are in carbon? Same as the atomic number, 6. How many electrons are in carbon? Same as the atomic number, 6. How many neutrons are in carbon? You take the mass, 12.01, and you round it off to 12, and then you subtract the atomic number. 12 minus 6 is 6, so our number of neutrons is 6. That's how you do it. There's no special magic. I don't need to explain it 1,000 other ways. If you don't know how to do that, that's how you do it. The atomic number tells you the number of protons and electrons, and the neutrons is mass minus protons. That's it. There's no magic there. Do that. So after you've determined the number of protons, neutrons, or electrons, you just draw them in the appropriate place. Our first example problem is boron. Boron is number 5 on the periodic table, so it has 5 protons. And that's what you're going to fill in your paper. This is number 9 on your paper. The number of electrons is also 5. Right here it tells you neutrons is mass minus protons, which is 10.81. So 11 minus the number of protons, 5 equals 6. So our neutrons is 6. So before you can draw a Bohr model, you need to calculate protons, neutrons, and electrons. In the nucleus are protons and neutrons. So you put P equals 5 in the middle and N equals 6. Now that's all you have to do to represent the protons and neutrons is put them in the middle. And now our electrons need to go in the energy levels around that. We have 5 electrons to distribute. The first energy level can hold 2. So the first 2 are in the first energy level. The remaining 3 of those 5, we've got to draw 5 of them. 3, 4, 5. We just drew 2 of them. We've got 3 more to go. They go in the next energy level. 1, 2, 3. And now we've drawn our 5 electrons. 1, 2, 3, and we're done. This is a Bohr model of boron. 5 protons, 6 neutrons, 1, 2, 3, 4, 5 electrons. We're done. Let's try another one. This is a Bohr model for carbon. Our protons equals 6. Our electrons equals 6. Our neutrons is 12 minus 6. That's our mass minus our protons, right? That equals 6. Now in the middle, you put P equals 6, N equals 6. Put your protons and neutrons in the middle. And now we've got 6 electrons that we've got to draw here. 1, 2, 3, 4, 5, 6. And you don't have to draw those off to the side. I'm just trying to help people understand. We've got to put 6 electrons in this atom. The first energy level holds 2. The second energy level can hold up to 8. So we've drawn 1, 2 of our 6. We got 4 more to go. I like to put them together in pairs. It helps me keep track of them. So there's 2, 4, and we're done. We've got how many electrons? 1, 2, 3, 4, 5, 6. So we've drawn all 6 of our electrons. Our Bohr model is done. 6 protons, 6 electrons, 6 neutrons. So now you need to get paper from me that has this on it. Number 11. Number 11. Come on, man. Number 11 is this one. And number 12 is this one. And you need to do them correctly and bring it to me. So a whole separate sheet of paper, you need to do Bohr models and bring them to me. If you're not able to do it, go back and try the 2 that we just did again. And then do number 11. You don't have to do both of them. If you're afraid you're doing it wrong, you can do the aluminum one first. That's number 11 on the second paper. Do it and bring it to me, and I'll tell you if you're doing it right or not. You need to put the number of protons, the number of neutrons, and then the number of electrons and the energy levels around the atom. Keep filling that in. So you need to put those things in there, bring it to me, and have me check it. Once you've done that, you can do number 12, and then you'll be ready to roll. And if you need to, before you try that, go back and watch the video again.